Okay. So number one's P.
Yeah, I'll just put it in the chat.
No, I can't hear you. Try again.
I wonder if maybe he has to mess with his settings like I had to that one time.
Are you on your phone or are you on your computer?
Bless you. Oh.
Thank you. Maybe you want to hang up Boogaloo and try over. Try again. That made no sense. I can't speak English today.
That's okay. We're doing math.
Hypothesis.
As long as your math is on point. Ugh.
Yeah. A confidence interval requirements, hypothesis test requirements, they're the same. Pretty sure. Right. Okay. So number 3, I just got P. Number 4 would be true.
And 5 you're thinking is also true.
Yeah. Are you just
putting them in? Are you just putting them in my never mind. Okay, let me look. I'm gonna pull up the reading.
Okay. I can wait if you're not ready. I thought you were ready, sorry man.
No, you're good.
Can you hear me?
Yeah.
Yes.
Oh, I don't know what happened. I just,
Computers.
Logging.
They suck.
Yeah, welcome back, Kevin.
Thanks.
Hope everything is good.
I mean, as good as it can get, I suppose.
Which question are you talking about?
We're talking about how Kevin's slow, like getting ready.
That's true.
Question 3 is C.
I'm good, man. I was really waiting for Lee, so.
Oh.
I was just making you think that it was me.
Okay, I'm on question 3. Question 3 is C, right?
Yeah.
Question 3 is C. Yeah. Question 4, it's just n times p hat, which is 10. So that one's good. And then n, so 100, it's 1 minus p hat, so 0.90 times 100, and that's more than 10. So 4 and 5 are true.
Okay.
Okay.
Number 6, a study of a first-degree murder of trials was conducted in another state. A random sample of 60 people on trial for the first-degree murder were taken. Of these, 45 of the defendants were found guilty. So the question is, find p hat point of estimate of the proportion of the first-degree murders who were guilty in this state. P hat would just be x over n, which is 45 over 60.
Yes.
I need my calculator.
I concur.
So 0.75. I had to do that. That was really sad that I had to do that.
Not really. It's just sometimes, unless you're like, I don't know. I feel like if you're not warmed up to doing math, like your brain doesn't work.
Yeah, no. By the end, I'm good.
Mine doesn't. Yeah.
So create a 95% confidence interval for the true proportion of the first-degree murder trials in this state. I can't read. There and the verdict is guilty. Input your answers in the margin of error, lower bound, upper bound.
Oh my gosh. There's like a stupid window right where the sun is coming in, where the computer is, and it's just bad. Oh gosh.
Oh.
So for 95, it's the 1.96, right? For the critical score or whatever.
Yeah.
Uh-huh.
At least I remember something.
M, we calculate the M, right?
Yeah, so there's that Excel document that I'm trying to open up right now. I didn't realize it's at the bottom of the lesson.
Oh yeah. There is.
Category data analyst.
Doesn't
I don't
that pretty much just do everything for you?
I think it does. Category data and Pat.
That's the greatest. Categorical data analysis.
I think it's the one that says hat.
Yeah, it is, because we've used the other two before.
Okay. So I'm going to cover you guys up. So 45 out of 60. Confidence interval of 0.95. Null hypothesis, we don't know. We want anything that is input your answers. Oh, I think we're doing. Is it not equal to? I don't know if it matters for margin of error.
No, it doesn't. So
I'm getting.
So I can't hold you, baby.
I'm getting 0.64 and 0.89.
Josie, come get your child.
The now hypothesis is how much?
I don't know why she even wants me so bad. She doesn't even like me.
The margin of error is 0.110.
Ben, sorry.
Yeah,
Hey, what is the now?
the null.
No hypothesis. Hypothesis.
You don't need it. You don't need it to get the confidence interval.
What did you get for the margin of error?
0.11.
Yeah, that's what I got. Yay! 0.11.
So,
I did it.
So, Brother Lou, if you don't put a null hypothesis in, you're not going to be able to get a z-score or a p-score, but you'll be able to get your confidence interval.
It's a point.
Your lower bound would be 0.640 and your upper bound would be 0.860.
0.64, right? The lower.
Yeah.
I mean, what is the margin of error you calculated?
Margin of error would be 0.110. So what I did is I wrote a formula underneath the confidence interval to calculate it for me. So if you just go p hat minus your lower bound, it will tell you your margin of error.
Okay.
Or if you go your upper bound minus your p hat, then you get your margin of error again too.
Okay, so the lower bound is 0.640, right?
Yeah.
And a 0.860. Right.
Yeah. Number 10, if you increase the sample size from 60 to 80, what do you expect will happen to the width of your confidence interval? It would decrease. Y'all agree?
Me.
Increase sample size from 60. What do you expect? Yes, decrease.
Yeah.
I talked about that in the textbook. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose that p equals half. What is the smallest n can be and both requirements still be met? Oh, I hate these questions, but okay.
I got it wrong the other day on the homework quiz.
I did too, because if you only use the first one,
remember the 4/5 one?
Yeah, no, I did it on the homework, and I just did the n times p, is greater than 10. But
Yeah.
when you did the n parentheses 1 minus p is greater than 10, it
Yeah.
gives you a higher value. So both of them have to be satisfied. Does that make sense what I'm trying to say?
Uh-huh.
So like right now, n could be
And it could be 5.
20. N could be 20, but now we need to test it in the other one to make sure it still works. Yeah, 20 would be the smallest one.
20?
Yeah.
How can you get the 20?
So n times 1/2 equals 100. I mean equals 10. So
Yeah.
then you just divide 10 divided by 0.5, and that equals 20.
And n times p, oh, that's different. Okay.
So you have to check both of those conditions to make sure they are satisfied.
Okay, it makes sense. So, yeah.
You get 20. Okay. Number 12, to conduct a hypothesis test for one proportion, 2 requirements must be met.
How did you get 11? I don't know how to do that.
Oh, sorry. I thought let me show you the textbook. I'm sorry that. Share screen. Okay, so right here, you see these 2 requirements. Those.
Okay, yeah.
Those 2 have to be fulfilled. So we know P,
Yeah.
put P in, and then change the greater than or equal to sign to equal,
hmm
and then just solve it algebraically. So do it for the first one, and then take your n value and put it in the second one. And if it still comes out to equal, to be greater than 10, then you're good.
Okay.
And if that doesn't work, then I solve for n with the other one, and then test it, because it has to fulfill both requirements.
Okay. So in this case, our n is the 60, right?
Yeah. No.
60.
What a different question. It doesn't
Oh,
use information.
Oh, well then what's n?
We don't
They
know.
asked you. They asked you to.
Oh, so to
find
figure out what
what's
n is. So I don't understand how you solve it then.
Okay, so n, you're going to do n times 1/2 equals 10.
Okay.
And then you just do
Okay.
10 divided by 0.5. And you get 20. So then you take the n equals 20 and put it into the other equation. So it's 20, parentheses 1 minus 1/2, parentheses equals 10. And check that the left half, the left side is equal or greater to than 10. Does that make sense?
I think so.
Okay. I think the next question is the exact same thing. So
It's just using a 1/10 instead of a 1/2.
um,
Yeah, it's using 1/10 instead of 1/2.
okay, so do you want to figure it out, and then I won't say what
If I can figure it out, he says. Good one. Nope, I forgot it.
Okay. So you're going to set the first equation up as n times 1/10 is equal to 10.
And gosh, my stupid erase doesn't work. N times 1/10 equals 10.
Okay. Now you're going to move that 1/10 over. So it's going to be 10 divided by 1/10, just to get n by itself.
Okay.
When you put that into your calculator, you get 100.
Okay. Okay. N equals 100. Okay.
Okay, now we're not done though. You have to check.
Yeah, then you have to put it into the other one.
Yeah.
So then you would do 100 parentheses 1 minus the 0.1 equals 10. Is that what you would do?
Yeah.
Equals or bigger than 10.
Equal, yeah. If it's equal or bigger than 10, then you're good.
So when you do that, it comes out to 111.111, which is bigger than 10, so we're good.
So that means 10 is 100.
It's pretty much 100 times 0.9.
Yeah.
Right. And 90. Okay, yeah. Okay.
I don't know why I said 101. I don't know what my calculator did. Okay. So 100 is our smallest value.
Okay.
So you have to do that every single time with every single sample to check that we can even do the sample. Those are the 2 requirements.
Yeah.
So, which
It made it seem easier in the videos.
Yeah, which would, like, I wish I would have, like, I've written down those requirements because on the test, there's so many questions about, does this fulfill all the requirements? And I was like, I don't remember what the requirements are. Okay.
So if the first number calculated is less than 10, so we just go with the second, right?
Yeah. Yeah. Okay. Number 13. For the water quality study, in a reading, about 60% of the, I don't even know what that is, water quality.
Macroinvertebrate water quality.
Whatever that is, indicated.
It's a kind of a bug, insect.
Ooh, I love
Bigger invertebrates, not microinvertebrates, macroinvertebrates.
have associated with good health. The researchers suppose that water quality in the area has decreased. They conclude a hypothesis test using significance of 0.05. Which of the following hypothesis? With the following hypothesis. Okay.
Ugh.
Okay. Just throw this stuff in the calculator. Oops, that's not an Excel document. Oh, where did it go? Do. Your confidence interval would be confidence level would be 95, right?
It doesn't say.
Well, isn't it when it's alpha, you just subtract alpha from 1? I saw something in the video about that.
Oh, I didn't know that.
Yeah, I didn't either. And then the video said something about it. It gave a chart of like confidence interval 95 of the z-score and then the alpha value. I guess there's a correlation. Whatever.
Oh, okay.
Okay, so for number 13, we have to just test that it's satisfied.
13 is 2.
0.6. Oh wait, p hat. What the heck? Oh. That's weird. I didn't know that. 38 divided by
80.
80. Yeah, so there's something in the bottom of the remember that if we want to find, if we were checking the requirements for the confidence interval, we use p hat. If we were checking the requirements for the hypothesis test for one proportion, we just use p. That was beautiful.
Sorry, let me answer the phone. 喂，你给我打电话。啊，没事，回头再说吧，我在开会。So, question 14 is 38 divided by 80, right?
Yeah.
So points 475.
Yeah, it's our p value, our p hat value.
Yeah. Find the test statistics. Are you using the the Excel.
Yeah. So for number 13, we just got to do that formula that we were just working on. So
Yeah.
it's 0.75 times 80, which is good. And then 1 minus 0.75, so it's like 0.525 times 80.
How
And
did you
that's
get
also good.
0.75?
Sorry, 475.
475. Where'd you get that?
38 divided by 80 to get, that's our p hat value.
Oh. Okay.
So number 13 is asking us if we're trying to test the hypothesis test.
Yeah.
And when we do the hypothesis test, we use p hat. When we're doing confidence interval, oh, I said it backwards. Crap. I did it backwards. 0.6 times 80. 0.4 times. We're still good.
So, are you looking at the question 15?
Yeah, question 15 is the z-score.
Yeah, it's
So
minus 2.282, isn't it?
Yep.
What was that?
Negative 2.282.
That was for 14?
15.
15. What the freak
Number
is 14?
14.475.
Okay. And
It's
to get the p hat, you do the crap. What do you do?
X divided by n, or put it in the Excel document and it tells you.
38. Okay, 38 divided by 80. Oh, that is true.
I just realized you did.
Okay.
So, what is the p-value for this statistic?
Kyrie, no. Josie!
Reject.
For a sec.
It's smaller, so it's reject.
Well, okay. First of all, we have to do the p-value. Number 16, and that's
It's
0.011.
yeah.
Oh wait, no. What is the p-value?
0.011.
Are we supposed
No.
to use the applet for this one?
Yeah, that's what I just tried, and it gave me a different p-value.
Yeah, here you go. No, there's some right here for you. Oh, is that where that goes? Here, that one. Here you go. Open that back up, please. There we go. There we go. Let's stick these in. Okay, we're gonna close. Close these.
I'm confused, to be totally honest.
Why you think it's not a 0.011?
Because Excel says 0.989.
0.989? Where is it?
It says p-value equals 0.989.
Are you looking at the applet?
Okay, I'm looking at both.
No, my p-value is 0.011.
On the Excel document.
Excel. Did you change the type of test to less than?
Yeah, I got 0.011
Yeah,
using looking at Excel.
I was wrong. I just read the sign wrong. I was so confused why that was even possible. Anyways, so the p-value is smaller, so we reject the null.
Yes.
And then the textbook gave a grade. Where did it go?
No.
What do you say for number 18?
Off the top of my head, I would think D, but I have been missing these questions of late, so I must not understand what's happening. So I'm probably wrong.
Well, we're rejecting the null. So there is sufficient evidence to conclude that the water quality in the area is not decreasing. So what was the original thought process? The researchers suspect that the water quality in the area has decreased.
I choose D. Either B or D. I mean, I think it's D.
I can check my work. I'll submit mine right now. With D.
D?
I got 100.
Look at that.
Looky there. That was pretty easy.
Yeah, that was. I mean, I'm not as good as I once was,
You used to be the
but
stats master.
I wouldn't say that, but I used to at least know what I was doing.
So you give Ben the chance to be sharper. Without
I'll give-
Kevin, so Ben is the one.
And I don't understand it. I got a 75 on that test.
Well, I'm probably going to get worse than that, I would imagine. So,
Which
Anyway.
yippee.
So on the homework here, I'm gonna stop recording. Stop broadcasting.